Again, welcome to Precalculus, Mathematics 164. This lecture covers applications of functions in business and economics. Our main objective is to formulate and evaluate total cost, total revenue, and profit functions. Also to find marginal cost, revenue, and profit, given linear total cost, total revenue, and profit functions. Also, how to write the equation of linear total cost, total revenue, and profit functions by using information given about the functions. So first, we start with total cost, total revenue, and profit. So the profit a firm makes on its products is the difference again between the amount it receives from sales, which is the revenue, and also total expenses, which will be the cost. So profit is always equal to revenue minus the total cost. So if we have X units that are products that were sold, then we can write our profit, which is P at X, equal to revenue, which is R at X, minus cost, which is C at X. Here we are assuming that S will be the number of products that were sold. So the profit, again, is equal to revenue minus the cost, total cost. So we have P at X equal to R at X minus C at X. P at X will be the profit from the sales of X units, and R at X will be the total revenue from sale of X units. Then the total cost of production and the sale of X units will be the C at X, which will be the total cost of both production of the X units and also the sale of the S units. As we know in business, the process of producing the goods, there will be some cost or expenses. Also, the process of selling the goods, there will be some expenses also. So in general, we say the revenue is found by using the equation revenue equal to price per unit times the number of units. So if I know the amount of product that I'm going to produce or I'm going to sell, and I know each price, then I will know the revenue. So for example, I have a product that is sold for $2 per unit, and I sold 200 units. So the revenue will be 2 times 200, which will give me $400. So to find the revenue is always the price per unit times the number of units. Now the cost is composed of two parts. We have the fixed cost and a variable cost. So fixed cost can be the cost that we are going to make even if we didn't produce any units of products. So example will be the lease of the building or the machines that were bought, the rent to be paid. These are fixed costs. So whether we produce a product or the company produce any products or not, we're still going to pay for the lease of the building. The variable cost will be the cost, depends on the number of units the company produce. So that's why we call it variable cost. It varies. Most likely when a company produces 20 units, the cost will be different from if it produced 40 units. But fixed cost is always constant. And whether the company produced 20 units or 40 units, is still going to pay for the rent or the lease of the building. So variable costs are those directly related to the number of units produced. So the cost is found by using the equation variable cost plus the fixed cost. So that will give us our total cost. Total cost is always two parts. We have the fixed cost, we have the variable cost. As we said again, the variable cost is related to the number of units sold, Fixed cost will be related to, example, will be the lease of the building, a cost that we are still going to get even if we produce 0 units. So let's try an example here. Here we say, suppose a firm manufactures MP3 players and sells them for $50 each. The cost incurred in the production and the sale of the MP3 players are $200,000 plus $10 for each player produced and sold. Now the question says we should write the profit function for the production and sale of X players. So we know the profit function will be the revenue function minus the total cost function. Now, when we look at this question, the company produces the MP3 players and sells them $50 each. So if we don't know the amount, or let's assume X is the number of players sold. So revenue will be 50 times X. 50 times X. We sold 1 unit for $50 and we sold S units. Number of units we sold is X. Now for the total cost, we have a sale of the cost incurred in the production and sale of MP3 at $200,000 plus $10 for each player produced and sold. So this means $10 will be our variable cost. So it will be 10 times X. It depends on the number of units that we sold or players that we sold. $200,000 will be a fixed cost. So from here, we can get our profit function. And also, if we know the number of units sold, we can find the total value for the profit and the revenue and the total cost. So as we said, the total revenue for the X MP3 will be 50 times X, which is 50X. So R at X is 50X. Then the fixed cost is $200,000. The total cost for X players, then it will be 10X because each player the company produced, they incurred $10 per 1 unit. So it will be 10X plus 200,000. So now we have the revenue function. We also have the total cost function. We know the profit function, then it will be revenue function minus the total cost function, which is R at X minus C at X. So we can plug in the values. Revenue function is 50X minus the cost function is 10X plus 200,000. So we have 10X plus 200,000. We open the parentheses and we combine, we get 40X because we get 50X minus 10X minus 200,000. So that will give us 40X minus 200,000. So this will be our profit function. Now, if we know the X number of units sold, then we can be able to again find the profit value. So here we have the diagram for the 3 items. The first is the revenue function. Remember the revenue is 50 times X. So when the X is 1, what is the value of revenue? To be 50. When X is 0, the revenue will be 0. So it starts from the center of the orange is 0, 0 for the revenue function. When S is 10, revenue will be 500, etc. Now the total cost function is 10S plus 200,000. We can also plug some S values and we can plot the graph. Same thing applies to profit function will be 40X minus 200,000. All the X, the variables are again, the exponent is 1 or the degree of the variable is 1. So this means all the equations, the graphs will be linear function. So next, let's go to marginals. So in example 1, we saw that both the total revenue function and the total cost function are linear. So the difference between the revenue and the total cost, which will give us profit, is also a linear function. Now, the slope of the profit function will represent the rate of change in profit with respect to the number of units produced and sold. And this is what we call the marginal profit. Normally, the term marginal always go with rate of change of something. So when we start calculus and we are doing derivative, they will tell us to find the marginal revenue. If we know the function of the revenue, then the marginal revenue or the marginal profit will be the derivative of the profit function or the revenue function. So the concept of margin again is rate of change. Here we say the slope. Also, slope is the concept of rate of change. As S move, how the Y changes. So as the S changes, also Y changes with respect. So here the slope of a profit function represents the rate of change in profit with respect to the number of units produced and sold. So this is called the marginal profit again. So similarly also, we say the marginal cost, which is MC, for this product is $10 because the slope of the cost function. And also the marginal revenue is $50 because we have 50x and the slope of the revenue function. Now, suppose that the cost in dollars for a product is given as the following: C equal to 21.75x plus 48.90. Now the question is, what is the marginal cost for this product and what does it mean? So here the cost function is given. We need to find the marginal cost. Again, if we are doing this using derivative, which we are going to do in the future when we start calculus, we find the derivative of this, the equation, which will give us 21.75. And that's the answer. And the same concept here. Here we say the equation has a form C equal to MS plus B. So the slope is 21.75. Thus the marginal cost is $21.75 per unit. So again, the same concept, but derivative, we may go through this method. So the question says, what is the marginal cost for this product and what does it mean? So the marginal cost was 21.75, which means, as we said here, 21 per unit, dollars per unit. That's the cost per unit. Because the marginal cost is the slope of the cost line, production of each additional unit will cost 21.75 more at any level of the production. So that's the whole concept of a marginal cost. The equation is given to us 21.75x plus 48.90. The marginal cost then will be 21.75 per unit because that's the slope. And what it means is that every time we produce an additional unit, the cost will be 21.75. So if I produce only one unit, it will be 1 times 21.75. If I produce 10 units, then it will be 10 times 21.75. So now let's go to break-even analysis. In business, the concept of break-even point is when a company doesn't make no profit and also doesn't lose anything. So which means the total revenue should be equal to the total cost. There's no profit. So in this case, profit equal to 0. And that's what we call the break-even point. So here we say we can solve equations for total revenue and also total cost simultaneously to find the point where cost and revenue are equal. And this is called the break-even point. So the break-even point is when the cost and revenue are the same, are equal. And this means profit is 0. The company didn't gain and also didn't lose anything. So on the graph of this function, we use S to represent the quantity produced and Y also to represent the dollar value of the revenue and cost. So the point where the total revenue line across the total cost line is called the break-even point, which we shall see in a few seconds. So here we have an example. A manufacturer sells a product for $10 per unit. And also the manufacturer variable cost is $2.50 per unit. And also the cost of 100 units is $14.50. How many units must the manufacturer produce each month to break even? So since we are looking for break even, we can write the function as R at X equal to C at S. Always break even is when the total revenue is equal to the total cost. Here, all the values are given to us. To find the revenue, we already know the amount per unit, the price per unit. So manufacturer sells the product for $10 per unit. So we can represent R as 10x. Then the manufacturer variable costs are $250. So it will be 250x will be the variable cost. And also, and the cost of 100 units is $14.50. So here we know the total revenue will represent for X unit will be 10X. So the equation for total revenue will be R at X, which gives us 10X. Then we need to find the equation for the total cost. So total cost will be C minus 1450 equal to 2.5X minus 100. The reason why the 1450 given to us is not a fixed cost. Here we say the first 100 and the cost of 100 units is 1450. So this means we are going to get C, which is the total cost, minus 1450. Then we can have 250x minus also 100 because 1450 gave us 100 units. The cost is 1450. So our function will be, when we evaluate this expression, our cost function will be 2.50x plus 1200. So now we know the revenue function, we know the cost function. Break-even point means when they are equal. So we get 10x, which is the revenue function, equal to 2.5x plus 1200, which is the cost function. So we solve this equation and we get x equal to 160. First, we bring the 250 to the left. So 10 minus 2.5 will give me 7.5x. X equal to 1200 divided by 7.5, and that will give us 160. So this means we have to sell 160 units in order for the company to break even. Break even means the company didn't make no profit and they didn't lose anything. So if we plot the graph, this is what we are trying to explain earlier. Break-even point also, you have two equations. I have the revenue and the total cost equation. So if you plot the revenue equation and you plot the total cost equation, the intersection of the two will be called the break-even point. It's called the break-even point. It's kind of like solving a system of linear equation. You have the total cost, total revenue. You can use substitution or elimination method to solve it. So next we go to the economics applications, which normally is supply, demand, and market equilibrium. So we say economists and managers also use points of intersection to determine market equilibrium. So the concept is almost same as a break-even point. Break-even point, when the company didn't make no profit and they didn't lose, the intersection of the two graphs, the revenue and the cost, will give us break. The same concept applied to market equilibrium. In economics, we have supply and demand. So we may have the supply function, we may also have the demand function. We can plot these two functions. The intersection of both of them will be the equilibrium point. Equilibrium point means when the supply and the demand are normal. So here we say market equilibrium occurs when the quantity of a commodity demanded is equal to the quantity supplied. So both the demand and the supply again are normal. They are equal. So demand, as we all know in economics, when we have too much supply and the demand are less, the price will go down. When the supply is less and the demand is high, the price will go up. So the best is the equilibrium market when the supply and the demand are equal. So we say demand by consumers for a commodity is related to the price of the commodity. So the law of demand states that the quantity demanded will increase as price also decrease. And the quantity demanded will decrease as price increase. So the law of supply also states that the quantity supply for sale will increase as the price of the product increase, and the other way around. So this is how the graph will look. We have the supply equation graph and we have demand equation graph. The intersection of the two will be the equilibrium quantity. In the x-axis, the quantity we need. In the y-axis, the price. So here we say that if the supply and demand curves for a commodity are graphed on the same coordinate system with the same units, and also market equilibrium occurs at the point where the curves intersect. The price at that point is called the equilibrium price, and also the quantity at that point is called the equilibrium quantity. And at the equilibrium point is where the supply and the demand are equal. When the supply is a little bit higher, demand is less, the price will start to go down. If the supply is less and the demand is high, the price will start to go up. So this means that when the price is $20 from the graph, consumers are willing to purchase the same number of units, which is 150. In general, the equilibrium price and also the equilibrium quantity must both be positive for the market equilibrium to have a meaning. And also we can find the market equilibrium by graphing the supply and demand functions on the same coordinate system. Then at the point of intersection is where we have the equilibrium price and also quantity. And as we have seen, finding the points common to the graph of two or more functions is called solving the system of equations or solving simultaneously. Sometimes we use the same solving simultaneous equation or system of equation. And we covered this in our previous chapter. So this is an example. If I have two graphs, we have a price, the demand equation, P is the price equal to minus 3Q, Q stands for quantity, plus 36. The supply, we have P equal to 4Q plus 1. So we can solve this equation using system of linear equation, either substitution or elimination. So at market equilibrium, the demand price equals the supply price. So solving this economics problem, market equilibrium, is using again system of linear equation. So here we equate the two together, minus 3Q plus 36 equal to 4Q plus 1. What we did is that we are using substitution here. We know P equal to minus 3Q plus 36. Second P is 4Q plus 1. So we can say minus 3Q plus 36 equal to 4Q plus 1, because demand equal to supply. So from here, we can be able to find Q. Again, we go back, when we combine the equation, we equate demand equal to supply, we find Q, because we have substituted P, which is 4Q plus 1 to the P, first P, and since demand equal to supply, then it will be 4Q plus 1 equal to minus 3Q plus 36. Now we bring our 4Q to the left, and we take our 36 to the right, so we get minus 7Q minus 35. Then later we get Q equal to 35 over 7. That's where we are now, 35 equal to 7Q. So Q will give us 5. Now, if we know Q is 5, we can take any of the two equations. Here we say P will give us 21. The reason why, since Q is 5, I'll plug in 5 in supply equation. So 4 times 5 is 20, plus 1 is 21. Or I can plug the 5 in the demand equation. So that will give me 5 times minus 3 will give me minus 15. Minus 15 plus 36 also will give me 21. So again, we are solving this problem using the concept of system of linear equation substitution. Then we can also check our answer. Plug in the value for Q, which is 5 in the both equation, 21Q. We will say that they are all equal. So now the next we're going to discuss about supply and demand with taxation. So here we say, suppose a supplier starts K per unit sold. Again, it starts K per unit sold, and the tax is passed on to the consumer by adding the K dollars to the selling price of the product. If the original supply function P equal to F at Q gives the supply price per unit, then passing the tax on gives a new supply function, because we are going to add the tax into the price. So we know that the supply function is F at Q. So if we had a tax to it, then it will be F at Q plus K. K is the tax. So because the value of the product is not changed by the tax, the demand function is unchanged. So the following figure shows the effect that has on the market equilibrium. So we can see here, before the tax, we have our supply curve. But when we add the tax to it, we can see that the supply curve move up, which means it increase. It increased K times. So this means our price will go up. So here we say, note that the new market equilibrium point is the point of intersection of the original demand function and the new after-tax supply function. So after-tax market, that will be our new. So here we can see that as the price went up, also the demand, the quantity goes down. So here we say the supply and demand function for dryers are given as the following. So we have the supply function, we have the demand function. Now the equilibrium point was 40 and 250. If we use substitution method to solve it, we say 2Q plus 170 equal to minus 5Q plus 450. Solve for Q. When you get the Q value, substitute it in one of the two equations, either supply or demand, and you get this value. Now, if the wholesaler starts $14 per unit sold, what will be the new equilibrium point? So here it's going to change. It's going to increase. So this means our function, previously, we can go back. You can see the supply function is 2Q plus 170, but now it increased 2Q plus 170. The tax is $14. So we had the $14, but the demand function will not change. It's only during the selling. supplier sell the tax. So this means we are going to get 2Q plus 184 because 170 plus 14 will give us 184. Then P equal to minus 5Q plus 450. So we use the same process. The supply equal to the demand function. We solve for Q. Q reduced to 38. And P, of course, will increase. So P gives us 260. So now Q is 38 and P is 260. And the solution. And we can see from the previous year, we have again 38 and 260. And the previous we have quantity is 40 and 250. So again, when the price increases, the demand goes down a little bit. So that will be the conclusion of these lectures. Again, these lectures, we use the concept of system of linear equations and also linear functions to solve a business problem, the cost function, the revenue, and the profit. And also we use the concept of system of linear equation to solve economics problem, equilibrium point, supply and demand, and also break-even point also. So again, wish everybody the best. Thank you.